Hello, welcome to Pre-Cal Lecture 2.3a, where we're going to talk about constant velocity problems. So you will need your pre-printed note sheet, and there are some problems, two problems on the front and two problems on the back that we're going to work. And we're going to use this equation, distance equals rate times time, or D is equal to RT. All right, so our first question, our example is Bob rollerblades 9 miles each morning. Today he averaged 10 miles an hour for the first 6 miles, but then slowed to 5 miles per hour for the rest of the trip. How long did the entire trip take? Okay, so we can divide this up into each leg of the trip. So we want to know how long, so we're solving for t. So t is equal to d over r. So for the first part of the trip, our time is equal to the distance, which was 6 miles, the first 6 miles, and his rate was 10 miles per hour. So that's equal to 0.6 hours. And then for the second part of the trip, he got a little tired. We know that it was a total of 9 miles. So the second part of the trip he traveled 3 miles, but he slowed down to half the speed, or 5 miles per hour. All right, 3/5, that's also going to be 0.6 hours. So the total time is 1.2 hours. All right. So let's take a look at the second example. Little bit fancier. It says Bill leaves on a plane traveling from Chicago to Los Angeles at 540 miles an hour. 1 hour later, Dave leaves on a plane traveling from LA to Chicago at 660 miles per hour. The distance between LA and Chicago is 1,800 miles. How long will Bill travel before the two planes meet, and how far from Chicago are the planes when they meet? Well, you don't have to do this, but I'm going to go ahead and draw a picture of this situation, kind of on a time and distance line. So let's say that this is Los Angeles, and this is Chicago. All right, and we have Bill leaves on a plane traveling from Chicago to Los Angeles, and then an hour later, Dave leaves traveling from LA to Chicago, and somewhere they meet. Let's say it's about right in here, because Bill got a 1 hour head start. So what we're going to call, so this is Bill traveling, right? And the question is, how long will Bill travel before the two planes meet? So we're going to call that distance D and time T, okay, from here to here. So distance D, time T. Now the whole distance between LA and Chicago, the entire distance, is 1,800 miles. All right, so I'm going to go ahead and remove this stuff here. Sorry about that. All right, so 1,800 miles total distance between the two cities. So from LA to the point that they meet would be 1,800 minus D. And then Dave leaves an hour later than Bill, 1 hour later. So we're going to call his time T minus 1 because he's leaving an hour later. Now, you don't have to do this every time. I'm just doing this kind of timeline and distance line for illustrative purposes. But what I would suggest that you do is make a chart. So we've got Bill and we've got Dave. Okay, so chart, we've got D, R, and T. So I crowded mine a little bit, but you don't have to on your paper. We know that Bill's distance is D. All right. And then, of course, Dave is going the other way. Right. Dave's distance is 1,800 minus D. Bill's rate is 540 miles an hour. And Dave's is 660 miles an hour. And then Bill's time is T, and Dave's time is T minus 1. So we can get two distance equals rate times time equations. Our first for Bill is D is equal to 540, the rate, times T. And then Dave's is a little fancier. It would be 1,800 minus D is equal to 660 times T minus 1. So this is just distance equals rate times time. I'm just going straight across my table here. Now we know that distance is equal to 540t, so we can make a substitution knowing that distance is 540 times t. So you always want one of them to be really the easy one. The d equals r times t. All right, and then you're going to substitute that in. So we'd have 1,800 minus 540t is equal to 660 times t minus 1. Now we only have time values. All right, so I've got 1,800 minus 540t is equal to 660t minus 660. So now it's just a linear algebra problem. Let's add 660 to both sides. So that would be 2460, right, that we're going to put on the left. And then I'm going to add 540 to each side. So that would be 1,200 times t. So we know that t is equal to 2460 over 1,200. All right, you can put that in your calculator, but it's 2.05 hours. Now we were asking for Bill's time. If you read the problem, how long will Bill travel? If we were asking how long would Dave travel, we would take that number and subtract 1 because it would be 1.05. But the question asked for Bill's time. So we don't have to make any adjustment. Now we also want to know how far from Chicago are the planes when they meet. Well, that's going to be distance, d. So d is equal to what? 540, right? We have this right here, times 2.05 hours. All right, so that's going to be 1,107 miles. So we found our t, and then we plugged into one of the equations, and this is the easier of the two to find d. All right, so whether or not you decide to do this kind of drawing here first to help you understand, that's up to you, but I would strongly suggest that you do a chart, and that's what we're going to do every time from now on is do a chart. Okay. So I don't want to forget, distance equals rate times time. And then the next example is, turn over your page to the back. We've got Art trains by running up a hill and then jogging back down the same path. He runs uphill at 200 meters per minute and jogs back at 120 meters per minute. If one circuit takes 30 minutes, how long is the hill? So one circuit is up and back down again. So let's make a chart. And I think the best way to organize the chart would be up the hill and then down the hill. So you've got distance, rate, and then time. Okay. So it says we've got to assume that up the hill and down the hill is exactly the same distance. It's just an out and back situation. Okay, so we've just got D and D there. There's no difference. The problem doesn't say there's a difference. Now the rates are easy to fill in. We know that he runs uphill kind of fast, 200 meters a minute, and then jogs back downhill at 120 meters a minute. Now we always want to make one of them pretty easy. So I'm going to make the top one just time, the time to get up the hill. But we know that it's going to take a different time to come back down the hill because he's going slower. But we also know that the entire trip takes 30 minutes. That's the sum of the two times. So this going down would be 30 minus t. And if you want to check that, if you do t plus 30 minus t, you get 30. So we know that works, right? So 30 minus t. We know it's something less than 30 minutes. So 30 minus t. So now we have two equations. Distance equals 200t, and distance is equal to 120 times 30 minus t. All right, and we can now substitute in 200t for distance. So I would have 200t is equal to 120 times 30 minus t. So 200t is equal to 120 times 30 is 3600 minus 120t. So if we add 120 to both sides, we'd have 320t on the left is equal to 3600. So t is equal to 3600 over 120, which is 11.25 minutes. Now that's not what the question is asking. The question is asking how long is the hill? Well, how long the hill is the distance. Okay, well, we know distance is equal to, we have two equations. I'm always going to use the easier one if I can. Distance is equal to 200 times time. So 200 times 11.25. All right, and that's 2,250 meters. So a bit over a mile. A mile's around 1,760 meters, I think. So maybe a mile and a third, something like that. All right, so pretty cool. If you make a chart, it really helps. All right, let's do one more. So the last one says, a car is driving 60 miles an hour on a highway beside train tracks. A train traveling 75 miles an hour passes the car. How long does it take the train to be 30 miles ahead of the car? All right. Well, let's go ahead and make a chart, and we'll divide this into car and train. So we've got distance, rate, and then time. Now, sometimes I like to just fill out the easy parts. And if you look at the problem, you know you're given the rate on both of them. Sometimes you have to solve for the rate, but in today's examples, you're given the rate. So we know it's 60 and 75. Now, are the times different? Well, the car and the train are both just traveling along. One didn't start later than another started, so we know that the time is going to be the same for both of them. It's not like our first example where one started an hour later than the other. They're just riding alongside, and the train pulls ahead. Now, one of them we usually want to be a simple distance equals rate times time. So I'm going to give distance to the car. We know that the train is 30 miles ahead of the car, so I'm just going to say that that is d plus 30. Okay? So now we have two equations, two unknowns. We have d is equal to 60t, and we have d plus 30 is equal to 75t. All right, and we want to solve for t. Excuse me here. So what I'm going to do is substitute 60t in for d. So I'd have 60t plus 30 is equal to 75t. So if I subtract 60t from both sides, we have 30 is equal to 15t. So divide both sides by 15 and you would have 2, and our problem is in hours, miles per hour. So miles and hours. So 2 hours is equal to t. So it said how long. All right. So we don't have to figure out what is the distance, how far the car is behind the train. Okay. But we could figure that out if asked, but it just asked for time. So we can stop there. And if we want to know the distance, we could plug, it would be 60 times 2 would be 120 for the car, and then 150 for the train. It's just a matter of plugging in. So make sure you read what is asked for and give that as your final answer. So the homework is going to be worksheet 2.3a. And there are 5 of those. I don't really have any special instructions. I would say just make a chart and use D equals RT. Right? We make a D equals RT chart, and then make sure you give the final answer that the question is asking. So if it asks for distance, don't give time. If it asks for rate, don't give time. You know what I'm saying? So the final answer that the question asks for. I know it's not good English to end in a preposition, but that's what we're going to do. All right, so good luck on the homework. Hopefully you find this interesting and not too frustrating, and I will talk to you on the next video.